Hi everybody, welcome to day 12. I hope you're all hanging in there. So the first thing I want you to look at is this triangle. Notice it's a 30, 60, 90 triangle. To review the ratio of the sides. But the first question I'm asking is, what's the relationship between angle A and angle C? And it's easy. All I wanted you to notice is that angle A plus angle C equals 90 degrees. And what do we call something or two angles when they add up to 90 degrees? We call them complementary. So they are complementary angles, angle A and C. So they add up to 90 degrees. Okay, you should be able to do this next part easily. I want you to find the sine of A, the sine of C, the cosine of A, and the cosine of C. So think about that. So if I start with A, the opposite of angle A is 1, and the hypotenuse is 2. So the sine of A is 1/2. The cosine of A, the adjacent over the hypotenuse, is rad 3 over 2. But then when I switch over to C, we have different opposite sides and different adjacent sides. So when I look at C, now rad 3 is the opposite side. So the sine of C is rad 3 over 2. And the cosine of C is 1/2. Okay. Now, because of that switch, so because of when I look at A, the opposite side is 1, and the hypotenuse always stays the same at 2. But for A, the opposite side is 1, but for C, the adjacent side is the 1. So what I want you to notice is, look, cosine of A and sine of C are equal, and the sine of A and the cosine of C are equal. The sine of A is 1/2, the cosine of C is 1/2. The cosine of A is rad 3 over 2, the sine of C is rad 3 over 2. And what do we know about A and C? We know that they are complementary. So what we call sine and cosine, we call them cofunctions, which should make sense because, look, it's sine and cosine, so they're called cofunctions. So if we think about these two sentences, read them over, see if you can think of what we're going to fill in the blanks. And what I'm looking for is that the sine of an acute angle, remember, we're always using acute angles because we're always using a right triangle, but we're never using the right angle, so they're always going to be acute. The sine of an acute angle is equal to the cosine of its complement. So what we saw up here, the sine of A was equal to the cosine of its complement. Sine was, A was 30 degrees. Cosine was 60. So those angles are complements. And then, of course, vice versa, the cosine of an acute angle is equal to the sine of its complement. There are other cofunctions, but you'll talk about them next year in Algebra 2. So the main thing is the sine of an angle equals the cosine of an angle only when the angles are, what am I looking for? Complementary. When A and B are complements of each other. This seems like a very easy concept right now, but when, the regents mix it up with a bunch of different questions, it might get a little confusing. So let me do a couple of these, and then I'll let you guys finish the rest. Number 1, find the values for theta. Remember the symbol for theta, that just means an angle. That make each statement true. So, when is the sine of an angle going to be equal to the cosine of 25 degrees? When the two angles are complements. So only happen when theta is equal to 65 degrees. You can get your calculator out and check. You'll always have your calculator right there, so you can always check to make sure that what I mean by check is check that sine of 65 degrees, put that in your calculator, hit enter. Then do the cosine of 25 degrees, put it in your calculator, hit enter. You should end up with the same exact value. Okay? I'm sure you could do B. Let me just do C with you real quick, and then I'll let you go on the rest. Same thing here. The sine of some angle is equal to cosine of some angle when those two angles are complementary. It's as easy as that. So I gave you a couple of questions to do, but you should also look over this top diagram just to make sure you understand what I'm doing here. All right, give this a try and Zoom with me later if you have any questions.